Prior to this time, water was carried off the deck using curb drains or grates. The orientation of those drains interfered with the placement of rebar. We can't interfere with the rebar that's connecting the rail to the deck. That's driven transportation agencies towards using a different kind of drain configuration that wouldn't interfere with the reinforcing bars. The alternative there is to use a tube steel, rectangular tube steel. It fits within the spacing between the rebar, so you can place the drain without having to cut the rebar. Therefore, you maintain the structural integrity of the deck rail interface. Initially, we didn't have a modeling method to calculate how much water flows into that drain, how much water flows by that drain. And of course, the amount of water that's flowing by the drain or bypassing the drain is going to accumulate and add to the pond width on the deck. And pond width leads to hydroplaning, and we have criteria to prevent that from happening. Hydraulics is very complicated. It's empirical and it's complicated because you can change a little thing, and analytically it takes a lot of computational power to calculate exactly what's going into that drain. Absolutely the best way to do it is to build a model and to run water past that drain and see what it does. The RTI project, the intention of it is to create a flume model. It would be 1-to-1 scale, it's full size, and basically test the performance of the drain under the different scenarios that you'd find it in. And basically the different scenarios are the amount of water that's flowing on the deck, the longitudinal slope of the bridge or the road surface, and the transverse slope of the road. It gives you that crown or your super elevation. So those are the kind of parameters that this test looks at and sees how those drains perform in realistic scenarios. We can confidently say that these drains are working at such a level of performance. Some of these flyovers, they're several thousand feet long. How many acres of surface is that? And you look at how much rainfall you get in a 10-year event, say, 10-year storm, you could have a full-blown stream coming off the end of your bridge. So, and for a lot of reasons, we have to get that water off the deck. Since the other methods that we used in the past aren't available because of the interference problem, this is a solution. It's being implemented. It's been being built in a couple bridges already. It's a new detail, and any new detail is going to, the contractors are going to have to gain some experience. We found that it's very important that when you build a rail, you want to make sure you maintain the base distance on the rail. Otherwise, if you drift, if it's called a mule, you're dragging the mule to slip form your rail. If that mule splays out on the bottom, it can actually begin to interfere with flow, or the hole that goes into the drain. So that's another careful thing you have to pay attention to.